Vibe coding is fun until the app has to survive contact with reality. The demo works, the button moves, the page looks decent, the agent says it finished, then you open the code. There are duplicate components. The auth check is decorative, the test suite does not exist, the database schema changed for no reason, the styling is scattered across 5 files, and the fix is somehow larger than the feature that is. Vibe coding slop, it is not AI coding. It is letting a model sprint through your repo with no rails and calling the dust cloud progress. The answer is not to stop using AI, the answer is to use better setups. Because there's a huge difference between asking an agent to make an app and giving an agent a workflow that forces good work. So here are 10 AI coding setups that beat Vibe coding slop. Some are local, some are cloud, some are cheap, some are boring, but all of them have the same idea underneath. Do not trust the vibe, build a loop. Hey, don't forget to like and subscribe for more like this. Now back to the video. Number 10 is the failing test setup. This is the simplest serious AI coding workflow. You do not start with a prompt that says build this feature. You start with a test that fails. Then the agent has one job. Make this test pass without breaking the others. That sounds less glamorous than asking for a full app. It is also much more reliable. A failing test gives the agent a target. It gives a task a finish line. It gives you proof that something changed for the right reason. Without the test, the agent can satisfy the prompt by making code that looks right. With the test, looking right is not enough. The setup can be simple. Write the expected behavior in a test. Tell the agent not to change the test unless it asks first. Tell it to run the smallest relevant test command. Tell it to explain any broader changes before making them. This immediately beats vibe coding because it turns the work from performance into engineering. The agent can still make mistakes, but now the repo has a way to push back. If you only take one thing from this video, take this. The best prompt is often not a prompt, it is a failing test. Number 9 is the spec first setup. Vibe coding often fails because the agent starts writing before the problem is real. The prompt is vague, the product decision is vague, the edge cases are vague, so the code becomes vague. A spec first setup changes the order first. The agent writes a short spec. What is the feature? Who uses it? What inputs matter? What should happen when it succeeds? What should happen when it fails? Which files are likely involved? Which tests should prove it? Then you approve or edit the spec. Only then does the agent write code. This works because many AI coding disasters are actually planning disasters. The model did not fail to write code. It wrote code for a half-formed idea. Spec first setups force the uncertain part into the open before files change. They are especially useful for product features, refactors, API changes, and anything that touches data. The spec does not need to be huge. In fact, huge specs often create their own problems. The best version is tight. Non-goals, acceptance criteria, files to inspect, tests to run, risks. That is enough to stop the agent from sprinting into a swamp. Vibe coding says, build what I mean. Spec first says, show me what you think I mean before you touch the code. That one pause saves a lot of cleanup. Number 8 is a 2-agent review setup. One agent writes, another agent reviews. Not as theater. As a real separation of jobs, the builder agent gets the task, reads the repo, makes a change, and runs the check. The reviewer agent gets a diff and asks different questions. Did this change more than the task required? Did it follow existing patterns? Did it add a dependency? Did it weaken validation? Did it skip an error case? Did it touch risky files? Did the test prove the behavior or just bless the implementation? This setup beats vibe coding because it introduces friction after generation. The builder is optimized for momentum. The reviewer is optimized for suspicion. You can do this with 2 different models, 2 different agent sessions, or 1 tool with a review mode. The important part is that the review agent should not be asked, does this look good? That question invites vibes. Ask it to find defects. Ask it to list risks. Ask it to compare the diff to the task. Ask it to name the missing test. Ask it what it would block in a pull request. Then you decide. Do not let the second agent become a rubber stamp. Make it the annoying reviewer you actually need. Number 7 is the local model scout setup. Not every AI coding task deserves the expensive model. A lot of work is exploration. Find where this function is used, summarize this package, list likely files for this bug, explain this error. Search for similar patterns. Turn this messy note into a plan. A local model can often do that work well enough. Then the stronger model handles a decision. This setup is useful because vibe coding often wastes expensive intelligence on wandering around. The frontier model spends half its time reading files it did not need. Then the hard reasoning happens with a cluttered context window. Instead, use a cheaper or local model as a scout. It maps the terrain, it finds candidates, it compresses context, it prepares the handoff. Then the stronger coding agent gets the smaller, sharper problem. This can be done with local tools, open coding agents, or any setup that lets you switch model providers. The point is not that local models are secretly better than frontier models. They are not. The point is that many steps in a coding workflow are cheap to verify. Use cheaper intelligence for those. Save the expensive model for the part where being wrong would be painful. That is not vibe coding. That is budgeted engineering. Number 6 is the command lock setup. Agents get dangerous when they can run anything and useful when they can run the right things. A command lock setup gives the agent an allowed menu. Run tests, run type checks, run formatting, run the app, search files, inspect, get diff. Maybe install dependencies only with approval. Maybe never touch deployment commands. Maybe never run destructive database commands. This setup matters because vibe coding often treats tool access as a power boost. More tools, more access, more magic, but more access also means more ways to make a mess. The serious version is permission design. Give the agent enough power to verify work. Do not give it enough power to casually damage the project. This is especially important now that agents can connect to browsers, terminals, cloud environments, GitHub, Slack, Gmail, calendars, and MCP servers. Every connection is a capability. Every capability is a risk. The command lock setup says you can move fast inside these rails. Outside the rails, ask. That is how you keep the useful part of agent autonomy without pretending nothing can go wrong. Number 5 is the worktree setup. Parallel agents sound impressive until they edit the same files. Then impressive becomes confusing. A worktree setup gives each agent its own copy of the repo on its own branch. One agent can investigate a bug, another can write tests, another can attempt a fix, another can review security assumptions. They do not stomp on each other because their changes are isolated. This is one of the setups that separates serious agent work from vibe chaos. Without isolation, you get overlapping edits, weird diffs, and no clear story of what happened. With worktrees, every agent has a lane. You can compare approaches, you can throw away a bad attempt, you can merge the best one, you can ask a reviewer agent to inspect only one branch. The trick is not to run 10 agents just because you can. That becomes its own slop. Use parallel agents when the work naturally splits. Research, implementation, testing, migration review. The more independent the lanes, the better this works. The more tangled the task, the more you need a plan before parallelism. Parallel AI is powerful, but only if the repo structure keeps the work from turning into soup. Number 4 is the docs as tool setup. A lot of prompts are just repeated instructions. Use this API, follow this release process, create a PR this way, write tests like this, check accessibility like this. Do not forget these files. Vibe coding puts all of that into the chat every time. A better setup turns repeatable procedures into reusable docs, skills, commands, or project instructions. The agent should be able to pull the right procedure when the task needs it. If the task is a database migration, it should use the migration guide. If the task is a UI component, it should use the component rules. If the task is a bug fix, it should use the debugging checklist. If the task is a pull request, it should use the PR process. The benefit is consistency. The agent is not relying on you to remember the same prompt every time, and you're not relying on the agent to infer process from scattered files. This is where AI coding starts to feel less like prompting and more like building a small operating system for work. The important warning is size. Do not make one giant instruction document that just creates a new context problem. Make small procedures with clear triggers. The right instruction at the right time beats a huge instruction all the time. Number 3 is the browser verification setup. For front-end work, tests are not always enough. An agent can pass unit tests and still create a broken layout. Text can overflow. Buttons can stack badly on mobile. A modal can open behind the header. A chart can render blank. A loading state can cover the thing users need. Vibe coding often stops when the code compiles. A browser verification setup makes the agent look at what it built, run the app, open the page, take a screenshot, check the important viewport sizes, interact with the feature, confirm the visible result. This matters because UI bugs are often visual, not logical. The code can be valid and the product can still be embarrassing. Agents are getting better at using browsers, screenshots, and computer control. Use that. Do not let front-end work finish at the file diff. Make the agent prove the user-facing behavior exists. This setup is also useful for debugging. Instead of pasting an error from the browser console, the agent can reproduce the bug, inspect the page, and see the result that closes the loop. And again, the loop beats the vibe. Number 2 is the no new dependency setup. AI agents love adding packages. Sometimes that is correct. Often it is laziness. Need a date formatter? Add a package. Need a small animation? Add a package. Need a validation helper? Add a package. Need a chart? Add a package that drags in half a universe. This is one of the easiest ways vibe coding turns into maintenance debt. A no new dependency setup says the agent must use existing code unless it asks first. If it wants a package, it has to justify it. What problem does it solve? Is there already a dependency that does this? What is the license? How large is it? Is it maintained? Does it run in the environment? Does it create a security or supply chain concern? This does not mean never add dependencies. That would be silly. It means dependencies are product decisions, not autocomplete confetti. The agent should treat them as expensive until proven otherwise. This setup is especially important with AI because agents are trained on examples from all over the internet. They may know a library exists. They may not know whether it belongs in your app. Make the default no. Good agents can handle that. Bad workflows cannot. Number one is the pull request shaped setup. The best AI coding setup makes every task look like a good pull request. Small scope, clear reason, limited files, tests included, checks run, risk explained, no surprise dependencies, no unrelated cleanup, no mystery refactors. That shape beats vibe coding because it aligns the agent with how real software ships. The prompt should not be make this better. The prompt should be produce a reviewable change. That one word matters. Reviewable. A reviewable change has a story. Here's the problem. Here's the approach. Here are the files changed. Here's how it was checked. Here's what remains risky. You can build this into the workflow. Before editing, ask for a plan. After editing, ask for a diff summary. Before finishing, run the checks at the end. Require a short review note. If the agent cannot explain the change clearly, the change is probably too messy. This is the opposite of vibe coding slop. It does not ask the AI to be magical. It asks the AI to behave like a contributor. That is a much better standard. So no, the answer is not to stop using AI coding tools. The answer is to stop using them like a slot machine. Better setups beat better vibes. Use failing tests, use specs, use review agents, use local scouts, log commands, use worktrees, turn docs into reusable procedures, verify in the browser. Make dependencies, ask permission, shape every task like a pull request. That is how AI coding becomes real engineering instead of a pile of plausible files. The model still matters. Of course it matters, but the workflow decides whether the model is allowed to be useful. Vibe coding says, trust me, it looks done. Good AI coding says, prove it. And that one difference is why one team gets leverage while another team gets cleanup.